All right, notes 8.3 are on average rate of change. So let's go ahead and read through what it says here. Functions are rules that give us outputs when we supply them with inputs. Very often we want to know how fast the outputs are changing compared to a change in the input values. This is referred to as the average rate of change of a function. So let's look at it, exercise number 1. Max and his younger sister Evie are having a race in the backyard. Max gives his sister a head start and they run for 20 seconds. The distance they are along in the race in feet is given below, with Max's distance given by the function m of t and Evie's distance given by the function e of t. So here's our graph right here. This function right here represents Evie's distance versus time, and this function right here represents Max's distance versus time. So question A says, how do you interpret the fact that m of 12 equals 30? Interpret your response by using the graph. So I have to use Max's graph right here, and I have to go to where my input is 12. So my input is 12 right here. So then my output, if I look at it, is right here, and it's 30. So that means that when my time is 12, my distance, or Max's distance, is 30, okay? So I would say after 12 seconds, Max's distance is 30 feet, okay? All right, so now question B. If both runners start at time 0, how much of a head start does Max give his little sister? So Max at the beginning is at 0 feet, okay? But then if you look at his sister's graph, his sister right here is at 25 feet. So I would take his sister's distance, which is 25 feet, and subtract his distance, which is 0 feet, then you get 25 feet. Okay, so, and that's how you can tell. So question C, does Max catch up to his sister, and how can you tell? Well, if you look at Max's slope, his slope is steeper, which means that eventually if I were to extend these lines, they would definitely intersect with each other, but we don't know how long they went for. So in the graph, they don't. So not in the graph. Max does not catch up to his sister in the graph, okay? But if they kept going, he would eventually catch up. Because the slope is steeper. All right. And then our last question here, question D. How far does Max run during the 20-second race? How far does Evie run? What calculation can you do to find Evie's distance? So Max started off by running, started at 0 feet, and then after 20 seconds, he reached 50 feet. So Max went 50 feet. However, Evie started at 25 feet, right here, and then after 20 seconds, she reached 60 feet. So to figure out Evie's distance, you have to do 60 minus 25, which is 35 feet. Okay? So then question E, how fast do both Evie and Max travel? In other words, how many feet do each of them run per second? Express your answers as decimals and attach units. Well, we know that Max went for 50 feet and it took him 20 seconds. So his speed is 50 feet for every 20 seconds. If you divide it all out, he's going at a rate of 2.5 feet per second. Evie, however, went 35 feet in 20 seconds. So her rate is 1.75 feet per second. Okay? Now, notice how, in order to get this 50 feet right here, what we did is we took Max's ending distance and subtracted his starting distance, and that's how we got 50. And then to figure out how much time went by, we took his ending time and subtracted his starting time, and that's how we got 20. Same thing with Evie right here. For Evie, we figured out her ending distance and her starting distance, and we subtracted those, and that's how we got 35. And then for her time, we took 20, her starting time, and subtracted her, 20 was her ending time and subtracted her starting time, and that's how we got 20 seconds. Now this should look familiar to you right here. This is just basically y2 minus y1. This is basically just x2 minus x1. So all you did to figure this out was just calculate the, hopefully you think the word is slope, okay? So let's take a look at what it says here. In the first exercise, we were calculating the rate that the function's output y values were changing. So the y values were changing, that's the same thing as saying delta y, right? Compared to the function's input or x values. So how much those are changing by. So that's delta x. This is known as finding the average rate of change of the function. You might think you've seen this before, and you have. So exercise number 2. Finding the average rate of change is the same as finding the blink of a line. See if you can fill that in. Come back to me when you're ready to go. All right, hopefully you said it's the same thing as finding the slope of a line. So there is, of course, a formula for finding average rate of change. Let's get it out of the way. So for the function y equals f of x, the average rate that f of x changes from x equals a to x equals b is given by this function, or this formula right here. So f of b minus f of a over b minus a. So it tells you how much the y values have changed. So again, that's delta y. And you're dividing it by how much the x values have changed. Again, that's delta x. Now, this is basically like the slope formula. X equals a is just your x1. X equals b is just your x2. F of b is your y2. F of a is your y1, and then it's over x2 minus x1. But I want you to be using this formula right here. Okay, so let's see, how do we apply it? Question number 3. The table below shows the average height of a tree and the amount of years that it has been growing. What is the average rate of change in the height of the tree from year 1 to year 5? So what I need to do is I need to use the formula f of b minus f of a all over b minus a. So your first x value that you have here is 1. So that means that a equals 1. Your second x value that you have here is 5. So that means that b equals 5. So then I have to figure out what is f of b. So I use my chart to help me figure it out. Remember, your height is your y variable or your outputs or your f. So I look at 5 and I figure out what f of 5 is. So actually, let's just plug this information in first. So you get f of 5, because that's what b is, minus f of 1, because that's what a is, over 5 minus 1. Well, f of 5, we figured out right here, is 9. So I would say 9, and then f of 1 right here is 3. So it's 9 minus 3 over 5 minus 1. So then you end up getting 6 over 4, but you have to understand what these numbers mean. So this 6 came from subtracting the output values. See right here how it says how much the y values changed? So it's your delta y. Well, y tells you your height in feet. So our difference in feet is 6 feet. Okay? And then the denominator tells us our delta x, or how much the x values have changed by. So this the x values represent time, and they're measured in years. So the difference in time is 4 years. So then when you go through and you actually divide it out, you end up getting 1.5 feet per year. It's really important you understand what those units mean. So C is the correct answer right here. All right, so now let's look at number 4. Compute the average rate of change of f from x1 to x2. Round your answer to 2 decimal places when appropriate, and then interpret your result graphically. So f of x equals x cubed minus 4x. I know for a fact that it's not a linear function. It's actually something called a cubic function, which you guys are going to learn about in the future. So don't worry about what type of a function it is, but I want to know what is the rate of change from 2 to 4. So if you take a look at this, I have to use the formula, which is f of b minus f of a is equal to over b minus a. So that means that my a value is 2 and my b value is 4. So I have to figure out what f of 4 is, and then I have to subtract f of 2, and then I have to divide it by 4 minus 2. So then, what is f of 4? So f of 4, the way I figure it out is by figuring out what my function is. So if f of x equals x cubed minus 4x, then f of 4 is 4 cubed minus 4 times 4. So then I end up getting, let me write this out a little bit more clearly so you can see this. So it's 4 cubed minus 4 times 4. So you end up getting 64 minus 16, which is 48. So that's what f of 4 is. But I also have to figure out what f of 2 is. So f of 2 is equal to 2 cubed minus 4 times 2. Well, 2 cubed is 8 minus 4 times 2 gives you 8 again, so you get 0. So it's 48 minus 0 over 4 minus 2. So you end up getting 48 over 2, which gives you 24 as your answer. So your rate of change is 24. And what it means is the slope of the line passing through these 2 points is 24. So next time I see you guys in class, we're going to talk a little bit more about the graphical representation of question number 4. Make sure you bring any questions with you to class so that way you're good to go. All right, see you later.